link-wise, again, to me, when we're doing these sheet metal particular parts, whether or not they're screwed together or whether or not they are welded together, there are just some cases where literally it's just easier to make multi-bodies. So, a question that came through, should the inside die radius match the radius of the part? Well, I guess in terms of, I guess my interpretation of that would be, I've always been, maybe it's not so much radius of the part, but radius, maybe I'm thinking this differently than here. Radius versus the thickness of the material versus maybe in this particular case as far as the actual tooling, as far as when that gets stamped, as far as if I want a 1/4 inch, do I increase or decrease that particular bit? That's, I believe, kind of what you're aiming at here with that particular question. I would, in my case, I would tend to match it. Now, what we're going to find, though, is depending on the tools that you have, you know, your internal, maybe you got an internal job, maybe you send a design out to a job. The tooling and the tool type, I should say, of the machine that's actually going to do the bending might be different depending on how it's bent, depending on the material itself, how springy is that particular material. So depending on the machine, a lot of times you need to make sure your print is very clear as to what you want, so the person that's going to actually be doing the bending, cutting, and forming of your part actually knows what he's doing depending on what tool he's using. That was really not that clear with that. But I believe there, again, you really need to talk to the person who's going to be doing that work for you. Again, that spec of that drawing is king, and that needs to make sure it fits. So no matter how much what they're doing, they know, okay, my interior radius is a 1/4 inch. So I don't care what tool they use as long as they get me a 1/4 inch radius on that internal. Okay. Now, another question that came here, terminology here as far as multi-body versus an assembly. Okay, I'll show you that here in just a second. So let's do that. Let me go ahead and start sharing SolidWorks here. So in a case, first, terminology-wise, with the question, what's the difference there as far as multi-body versus an assembly? Okay, so for instance, in this particular right now, if we notice here, we're in an SLDPRT file. Okay, it's not hard. But if I look here, and at the moment right now, because this is called the sheet metal, it's called a cut list. If I was just in a stock part file, and I just did a couple rectangles here, and I did an intrusion with this, okay, if we look in our tree here, we also in this part file 2 separate bodies. So we're still in a part file, okay, with this, but we have 2 separate bodies. So this is a multi-body part file. As far as an assembly goes, right, we would see this where there would be individual components all plugged in together. So let's say, for instance, here the vise. Okay, this is an assembly that has multiple components into it. Now, what gets interesting here, and we're going to see this in the example here today, is the fact that we could have 1, 2, 3, 4, 5 parts, but then another part that is technically a multi-body, okay, to go along with it. So one part file might contain multiples. This is usually, now we're talking about sheet metal multi-body, but what we're finding SolidWorks-wise is really sheet metal and the weldments, as far as how they act, are really starting to blend together. The big difference between a weldment and a sheet metal multi-body is the fact that a sheet metal can unfold. Okay. Other than that, as far as the interaction, how we assign properties, things like that are becoming very much one in the same. And it looks like I might have an issue once again with the voice. Is there anybody else? Is that please go ahead and post in there if it's not just me that is, as far as one person that's up over choppy. Is there other folks that are experiencing the same thing? Yeah, it looks like one or two. Okay. All right. So it looks like maybe a few folks. So one there, it may be like network traffic on there. Usually, if it's everybody is having an issue, it's well, a couple people there. Okay, let's do this. Go just a little bit more, and if it just keeps being really terrible, I'll switch phones. It'll just take a second to do that. Okay, with that, I will be happy to change that over if it just keeps being terrible. Okay, so go a little bit more here. So we kind of understand the difference here between it says now between what a multi-body part and what an assembly is here. Now we can still do it the old-fashioned way. I shouldn't say old-fashioned way. The other way of single part, put it into an assembly. Do another single part, put it into an assembly. If you take an Essentials class in SolidWorks, that is what you would do in the last chapter of the book. It's a bottom-up type assembly. So we have to put these things together and then be careful about where we assign hole locations if we're going to screw these things together, bolt them together, or, and maybe in our case, weld them together with that. Okay, so again, could be multiple ways that we want to put this together. Now, the advantage here with sheet metal and multi-body is we don't have to worry about mates. We can have one file driving where all these bodies are. And technically speaking, we can take, as what we're going to see here, a multi-body file and unfold them individually. Okay, so one part file will contain a whole bunch of things, okay, with it. So let's take a look at potentially doing a few of these. I want to do something here real quick. Before I get into my example, though, I want to grab my cell phone, which is just out of arm's reach. I'm going to grab it just in case this, with the voice, it keeps getting bad. So give me just a second and grab that. Okay. There we go. All right. Okay, so let's take a look at an example here. So first off here, get to my desktop here. Let's take a look at just the start of a simple example. Okay. This one might be some sort of handrail. Now, this is really a multi-body class, isn't so much how to do sheet metal, okay, with it here. So some of the steps might kind of, I might go kind of quick on a few of these particular steps here, but this is just a good example in this particular case where we've got, again, some sort of a handrail, right, and a bracket here. Now, take a look at the tree up here. I can see here I've got a cut list. Okay, and now in 13, they decided to change up the symbols, okay, a little bit here in the tree. So in this particular case, I actually have a couple things going on. I started out as a weldment because I used this as a tube. And then I went ahead and made some sheet metal parts here on the end. So this is, again, technically an assembly. Right here, but we're in single part files. So let's just take a quick look. I'll do a little bit of an example of this. Well, I just started out here just by drawing just a single line here to represent that particular tube. Now, let's take a look at the tree, which we just see a solid bodies folder right now. As soon as I go to a weld here and I say I want to do a structural member here, and I go ahead and pick on it, I get a tube here. Now, as soon as I either if I did a sheet first or a weldment first, it doesn't really matter. Okay, both of these, again, are going to change, and we're going to see, instead of a solid bodies folder, we're going to see a cut list folder. Okay, now, occasionally here, as you build bodies, it doesn't matter what you're doing here, we right-click here, and we update that. And as soon as I do that, I see that little yellow box there from just a plain Jane body symbol turn into the little weldment symbol. Okay, and it kind of matches the one up there to let me know, hey, you're doing a weldment. And we know weldments are essentially profiles, okay, that we get from a standard rectangular I-beams, tubes, that kind of thing. And it's essentially a glorified sweep with this. But now what I want to do here is go ahead and design some bodies. Now, I may not get quite as fancy. There's all sorts of ways to build bodies. And we're going to look at a couple different ways with that to do sheet metal in whichever way you might find it. So, for instance, I'm going to go and I'm going to start just with the flat plate. I'm going to take advantage here. I'm a big believer in, again, if I've done it once, I want to try to reuse it. So that might be things like using dynamic mirror, especially when we do symmetrical parts, as we saw here, or we're going to see here again here in a second. So I'm just going to go ahead and dynamic mirror here. Okay, and go ahead and zoom it up, and there we go, and dimension it. Okay. Now, it's things like this where it makes it really, really nice to be able to be doing this all within the singular part file. For instance, I want to do this, so I just have just enough little area here to throw in a bit of a weld bead on here. Okay, so I could just give it just enough extra room on there to do something like that. Okay, so I'll do something here, and just make sure I've got a tendency there. All right, so now I'll head to Mobile, and I'll go ahead here and do a flange tab. Now, again, nothing particularly new for those that have been using sheet metal. Again, this is kind of multi-body, but we kind of have to get through these steps, again, to get there. All right, so once again, we can either use a particular gauge table if we'd like. Remember, these gauge tables are just Excel. Okay. You know what, folks? It looks like, give me a second here. It looks like we're going to need to switch phones. So give me just 2 seconds here, and I'll call right back in. So just a second. Give me 2 seconds. Okay, there we go. Let's try this now. Hopefully this one will be a little bit better. Okay, so let's go ahead here. We'll keep on going with this. Just a reminder for everyone too, the session is being recorded, so you will be able to get access to that later on. I'm just going to ask our marketing department when they get that sent out. So we will definitely
like I said, we'll definitely be able to, if you miss a little bit of it or whatnot, you'll be able to get to that. Okay, so I'll go ahead here and assign here just any kind of table, okay, or a particular gauge. Okay, and what I was saying there, these are Excel tables, so you can go in there and modify them to your heart's content. The biggest thing that I really like about this, especially if you, the last job that I worked at, we did fabrication for material handling racks. So we had a set amount of tubing in stock, we had a set sizes of sheet metal that we had available to us. And what we can do here with this is say, okay, well, I want inch, and on those Excel tables there, you can put in there or specify we should do a particular, you know, we only have these materials in stock. This is what we build with. If we look at a list of all the available gauges that we can buy, I mean, there's a ton of them, and nobody wants to buy or specify that one, you know, sheet that's not commonly made. And because of that, it costs way more than other ones to buy. So you can limit that as far as what gauges you have available in your drop-down. The other thing here for you, tell it what you want your radiuses to be. Okay? We don't want to have, we might have a quarter, a half, and a 1-inch tool to do bends. Okay? We might not have a 5/16 on hand to do a bend. Now, if a particular project absolutely insists that this needs to be a 5/16 bend, okay, we're going to have to buy a tool. However, we can specify again in that particular Excel sheet what we have available. Obviously, they can override what that might be, but this drop down here as far as the lists that are available to me, okay, we can control that again in that Excel sheet. So from a little bit more administrative level, if you're kind of a 1-2-man show, you may just have your own copy as far as these Excel sheets sitting local. However, if you're in a job shop atmosphere where there are 3, 4, 5 people, you want to make sure everyone's using that same Excel type spreadsheet, okay, to access these. That way, everyone's kind of on the same page. And again, one person isn't speccing things that we barely ever use or we don't have a tool for. All right, so I'm going to spec that. Now, with that, again, that particular gauge, that's an interior. All right, with that, and let me just specify here. We'll go 10 gauge. Make that thickness go out. Now, here's another thing. The advantage here with being either already in a weldment and or sheet metal part is the fact that as I create these bodies are not going to be by default merging with each other, okay? Because either, again, sheet metal weldments, they're wanting to be separate. They're assumed to be separate, okay, with that. So I'll hit OK on this, and we'll start there. All right, so next up, I'll come up here and just go ahead and throw an edge flange, okay, on here to give it something to come out. Again, you have all sorts of options, material inside, the material outside. I want the bend outside. If it's at an angle, I can bend from a virtual sharp. So again, all sorts of options, okay, of where we want to connect to here. All right, so in this particular case, I'll do material inside, and if I look at this from the top, we're actually kind of peeling this back and adding out. Now, the other thing with this is this profile here. We can specify an overall distance if we want to, okay? And in this case, that's fine. Okay, so I can say I want this to come out 1.5 inches. And there we go. All right, now, with one particular body, it's no big deal. We come up here to the sheet metal tab, and I'll come over here to flatten. Okay, and click on that flatten and watch what happens. Whenever you have anything multi-body, okay, and again, right now we just have one sheet metal part, obviously. So just everything else body-wise kind of disappears while this particular bit flattens out. All right, so I'll take it here and push this up. Now, in our case here, this might be similar left to right. Okay, so again, I'm going to take advantage of mirroring here, okay, for this particular body. All right, over to my opposite side. Now, I'm going to take a look at my cut list. I'm going to right-click here on my cut list and update. And even though this says automatic here, that does not mean automatic update. I wish it did, but we come in here occasionally, and what it does is clean this up, organizes my bodies. Even though this is a weldment symbol, and even though this is a little sheet metal symbol, it's a folder, okay, that contains bodies, and that contains similar bodies. Okay, between these two. Now, what if, for instance, in this particular case, one side required some holes in it? Okay. Now, I normally maybe use Hole Wizard or something along that line, just for time's sake here. I'll just go ahead and throw in some sort of a slot here and give it a cut. Okay. Remember with sheet metal here, when the cut command, extruded cut command, whenever you're in sheet metal here, we have now a button here to say link to the thickness of your material, okay, that you specify. Okay, so we'll say okay, and we get a cutout. Now, let me, once again here, let me refresh or update my cut list. Now let's take a look. Now these are two separate bodies. Even though the general shape is the same, well, obviously one has a hole in it now, and one does not. Okay, so in this particular case, how do we see each of these flattened? Okay, when we open up the flat pattern folder here at the end, we see flat pattern 2 here and a 4. It's basically the particular body, okay, between the two. This is the easiest way I found as far as just to double check your flatness, okay, or your flat pattern in here. You can try to do the flatten, but when the flatten button here does, if we've got multi-bodies, it's only going to do the first button, or excuse me, the first body. All right. The easiest way I found, right-click directly on the body here in the tree and hit flatten. All right, so I'll do another one here, and we'll see this one flatten. Okay, and I can exit the flatten. Okay, so it's kind of interesting because I'll take here, I'll tell it to flatten this body, but I can come back up here to the sheet metal tab and uncheck it to come back out. Okay, so maybe over here. Do a couple holes. Okay, once again, link to thickness, and again, they're still different here. All right, with that. Now, at this point, again, maybe some other spec of some sheet metal part. Okay, so let's look at doing something like that. Okay, so here. All right, now I want to talk a little bit, again, symmetry, okay, with this. Now, I'm going to take here, do a little bit of construction. And bring this on over here. And just dimension this to here. All right, to say, let's do 3/4 of an inch. All right, so now I'm going to go ahead and just draw a line. And again, as you saw there when I did this, well, in this particular case, I don't have to do any kind of radiuses, okay, in the corners here. So here. Okay, I need to get that lined up. Hang on a second. There we go, coincident there. Okay, so I'm just going to do half. I'm going to just do it right here. Okay, if I need to maybe change that, I can change that in a little bit here, but I'm going to go ahead and extrude this one. Okay, this time I'm just going to go this base flange. Okay, so I'm going from the side here. I'll do a mid-plane extrusion. Okay, so let's see here. That'll work. About 4 inches here. I think this is mounting to something, okay, with this. Okay, so we do it there. Now, what I might do next, I'm going to take here, I'm going to again do a here, okay, about here, and near this body. Okay, now, in this particular case here, like I said, it's I've got the ability to merge or not merge with this, and because this is sitting flat, again, if I take here and do an update, it's kind of regarding these last two bits as two separate pieces. So I could, if I would have picked merge in this, let's see what that would have done. Okay, and notice here with this merge along that seam, it's just merging that one reflection there. All right, so once again, let me go ahead and save this part. All right, and I'll come up here, update my cut list. All right, and once again, easiest way, right click and flatten on your parts. All right, now let's take a look here. Notice in 13 here, SolidWorks, we have the gray kind of sketch line here. Okay, so like a center line. That's the immediate center of the bend. Okay, you can choose if you'd like to have the face of this sheet metal part broken up to represent where the bends stop and the flats start. It's a property of the flat pattern down here. Right, and you can tell it basically it says to merge faces. So instead of again keeping all these separate faces here, we can merge it and it'll look like nice one big rectangle. It's up to you how you'd like to show that, because maybe what's really important is a dimension to the start of a bend, not necessarily to the center of a bend. Okay, so either way you can spec it depending on what you might be looking for. All right, now we've done here, we've got some bodies that we have in place. Let's talk a little bit about the properties now, right, of these individually. So, for instance here, my bar that I've got here, again, it's a weldment piece here. Now, if I want to spec everything the same material, and what I can do here is, and I'm going to just do this for a weird color. Okay, so you can, it's easy to identify here. I'm going to say, okay, everything is copper. Okay, so if I assign that at that top level there, everybody becomes copper. However, I can, if I want to, assign individual pieces something different. Okay, to do something like that, we'll take, for instance, this last bracket piece here in the back. All right, I'm going to right-click on the body itself, all right, and I'm going to assign then a material. You can do the edit material just like you would in your normal one, and you can go navigate through and find whatever material that you're looking for. So I'll spec this one. Okay, again, and I'm not so much worried about materials as I am just colors, so you can see the difference here. So I'll do this one, the AISI 1020 steel here. Okay, so if I assign a material, notice what it does here in the tree. You see the little material symbol here underneath that body. So that overrides whatever you have as the main property. Now, in the case here where I might have two of the same components, right, where again, if I hadn't done this differently, I can also assign, even though the component is dimensionally the same, say one side is gold and one side is silver. And when I do that and update my cut list, those will be two separate parts. Again, because they're dimensionally the same, it doesn't matter now because the material. So as long as the two things are identical in every particular respect, they'll stay all in the same folder there. Okay, so once again here, we'll take this item and assign this material, again, something a little bit different here. Right, with that color. All right, now, when we do this, a multi-body solid, when we want to push this to a drawing, just remember that we assign the properties a bit different now. Okay, we've just been kind of messing around on the outside here with assigning a particular just because I'm writing this menu here, we can display these bodies differently if it helps us during building. This doesn't matter about bill of material information or anything like that, okay? But I can say, well, I'd really like to have that part hidden line removed to make it easier to see. Easiest way to manipulate that, the little double arrow there, your display pane at the top there. And let me just move this on over and point to it right here. Little double arrow. First column here is a bunch of hide shows. Second column is changing that display. Okay, so if I really expand all these out, okay, I can again change these to shaded with no edges or whatever in particular that I'd like. Now, I can also, again, with that visually, take something and turn it transparent. And again, these are visual things. You can always use display states. Again, if we start getting a lot of overlapping parts, if it makes it easier for you to change colors, to do these things, do them. You can, in the case of colors, you can always get rid of them at the end. And again, if it makes it easier, use that. Okay, so other things that go with this, and this is really cool about sheet metal. Watch this now. Okay, I'll give it a save. I'll do one more update here, which I don't think that really did anything here. But what I'm going to do now is right-click on any of these in the list, the cut list here, and go to Properties. Okay. Now, if I pick on this, look at all the properties now, okay, that comes with this. We've got bounding box length and width. So what is the raw square material, okay, that I need in order to see how much material that I start with to make this particular part. I got sheet metal thickness. Okay, I've got cutting area. Okay, so it traces the outside. How far do I need? You know, how far does it take to take a pair of scissors, a manly pair of scissors, to cut all the way around? Any particular cutouts? It seems the more over the years SolidWorks has developed sheet metal, there's all sorts of stuff that can be thrown into a bill of material here by default. Okay, the ones we're worried about here for today, okay, is material, okay, mass of a part, okay, our description here. Okay, so this one here. Now what I'm going to do is just make sure anything that I do as a property here of the weldment cut list, I'm just going to put a well, yeah, it's called a weldment cut list, a WLD at the end of it. Okay, just so I know, because when we go to do a bill of material here with a multi-body solid, we're picking a weldment cut list out of the option. There's no such thing as, it's not labeled sheet metal cut list. Okay, with that. So we're using a weldment cut list, okay, when we do a bill of material here. Okay, so again, all sorts of great stuff here, okay, that we can specify with this. Okay, so I'll go to this one. Now what's nifty here, this will take here and highlight what we got going on here so it's easy to see. But even better is if I would have renamed these. Okay, to have these. So let's keep going here with this. Okay, bracket left. Okay, do number 2 here. This one, bracket right. Okay, and the first one here is my tube. Now notice with a weldment, okay, with just that tube, there's an awful lot less, okay, that's in there. Okay, just because again, there's no flattening involved, anything like that. The important thing here is the fact that we do get a length assigned with something like that. So let's see here. Let's hit OK, and I'll give it a save. All right, so now I've got, again, some materials, some of them specified, some not specified here. We'll just make it final, and we'll just do all sorts of different materials in here. Okay, and we'll make a plastic tube, although, yeah, we're going to weld a plastic there. So, again, anyway, it doesn't really matter there in the material here, just, again, showing different colors. So, I'll give this a save, and I'm going to go ahead and drop this into a drawing. So, File, and I'll make a drawing here. All right, that's this. Okay. So now got a drawing here, and I'll just take here. Let's just shade it just to make it a little bit easier to see here. All right, so I got multiple parts here. Now the next thing is how the heck do I get this to see these individual bodies in here? And this is one of the easiest ways that I found in order to do this. Let me add a second sheet. Okay, and there's a couple different ways to go about kind of getting this information into the view here. Again, regardless of how you get it into the view, and in the end here, okay, I'm going to bring this this view in here. Okay, I'm going to specify here. We'll do a front view, but as soon as I drop this in here, I'm going to come up here to the top of this property the property of this particular view and go to Select Bodies. And when I do this, I can start picking the particular body that I want. And I'll start here with this back here. Okay, so I get a back. If I were to, let me just for the moment project this up just so you can see. Okay, here, or take and turn this to, there we go. Hidden line visible. Okay, what I can do as soon as I see, or SolidWorks sees that it is just an individual part, I can come over here to the properties of that drawing view and click on Flat Pattern. Okay, and I will flatten that out. Okay, and what you can see here, and I left it here. Notice it is in fact longer. Okay, with the flatten. Now, when I do this, there are different ways here that I can assign where I want to have these labels at, or if I want to have these labels. Let me, for a moment here, let me turn off sketches. Okay, so we can kind of make that disappear. Or if I want to see sketches, that way I see potential bend lines here. What I'm actually seeing here in this is the sketch inside of here. And let me find it here. There we go. I'll hide it. There it is. Okay. Now, let's take a look at some of the options as far as where, again, how you assign this. You would do this ahead of time. You're going to decide, I want leaders. I want no leaders. I want colors on bend lines. It's all sorts of stuff here. It's just like any other regular drawing template. You want to assign these types of things ahead of time. Okay, so I'll go into my options here. Document properties, and right down here at the end is sheet metal. This is another area that has expanded greatly in 13. Being able to have just a few more choices of things, how you want things to show up. This used to be pretty simple. There's one, and just basically where you wanted the anchor and colors. Okay, and now we can kind of push these things around. Again, where do we want the leader? Do we want above or below it? This is the kind of thing, though, we can change this after the fact, just like anything, like shading views, hidden lines visible, turning that on and off, whatever you want. You can always do this after the fact. Up here, if you have a color printer or prefer to have colors on here, I can say, well, anything that's in an up direction, I can assign it a color. And anything that might be going in a down direction, assign it something else. Okay, with my colors here. So I'll say OK. Notice we get a color change here with the labels here. I can say, well, I want this leader on here. Now, the orientation of the text here. Okay, if I click on this, notice again we have it. It's by default the way this part is orientated right now. I can change this to 0. and move these things around. Depending on how your part is oriented and everything, like there's a lot, again, option-wise that goes in here. You just got to do it a few times on your own part in order to do that. Now, we've just done our one part here. Right, so I can take here, and once again, you can either, again, another method here, instead of dragging and dropping views in, is to just go ahead and copy a view. Right, you can take a view here, Control-C to copy it, Control-V to paste it. Once again, select bodies, and say, well, this time I just want this one. Okay, so once again here, let me go back here and hide that line. There we go. All right, with it here. All right, so in this particular case, once again, I might say, well, I wanted this maybe in a potential different orientation. Hang on a second here. There we go. All right, so maybe in this particular case here, and I think I messed something up here. Hang on a second. Let me do that one more time. There we go. Look at this. Oh, let me save here and regenerate this. There we go. Little glitch sometimes. Occasionally we get some of the options that hey, why isn't this option showing up? Usually click save here. Okay, takes care of that. There we go. Let's just throw this in here. Get rid of that one. I do pick my body. Okay. And we do the same thing. We go do your flat pattern there. Do that one more time. This is bugging me. Normally at this point I probably shut the drawing down, start it back up again, but let me just do this one more time. There we go. That's what I want to see. And now I can do my flat pattern. Oop, I exited out beforehand. Sorry about that. One more time. Select my body there. Flat pattern. There it is down there. Okay. So I'll do Control-Q there. I'm having some graphics issues with this. Anyways, here, this is what I should be seeing here with this parent here is, yep, hang on a second. Let me do, there we go. Weird graphics on my end. Okay, so there we go. So we got a flat pattern there. So it's a simple matter again. Bring that assembly in, hit that select bodies, go pick the particular body. Before you even get to the point of dropping it, you can go ahead and hit that flat pattern option there. So you can get all these flat pattern bodies individually and then go to town on dimensioning them. Okay, so pretty simple. Okay, work with that multi-body. And again, the idea here is as I put this together, if I've got close tolerances on particular items, again, it just might be easier to put this together in a multi-body setup. And again, we can have different materials, call out information here. Let's do a bill of material here. All right, so let's take here. Annotation tab, tables at the end here, and because this is a single part file, okay, we're going to do a weldment cut list. Let me show you kind of the difference here, okay, with this. So first off here, I'll do a weldment cut list, all right, and pick here, and I just have a generic setup right now as far as what this with this weldment cut list. Now I took the time to go ahead and put these descriptions in. And these are a little bit different than the descriptions or how you would interact with a regular bill of material. Okay, so this is, again, this is a weldment cut list. So a few things here. Now, notice here I managed to lose the description here, okay, of this particular second part here, which is that backdrop. So let me open this up and get that. And let me go to the properties here. No, that's interesting here. Why am I not seeing? Oh, let's see. Oh, the right. That's why I got the wrong part. That would help. Okay, so it's the right weld there. There we go. And this is another neat thing that 13 is doing now is the highlight. This used to be kind of a, and again, in multi-body, it was tough. If I had a ton of multi-bodies here, as I would click on here, where is that in my tree? And now, nicely, it's selecting here for me. Let's go to this one. There we go. Okay, so bracket. All right. There we go. Okay, save. Okay, and there we go. There's our update. Now, I want to add properties, okay, to this, one way or the other. Like, for instance, that bounding box. Okay. Again, normally what we would see here is some of this is the same, but check it out. Instead of having what the property is available to me in a normal bill of material kind of up here on the top, it shows up here in the property manager. Again, it's different. It's always been like this, where it's just slightly different. And what I've been told sometimes by some of the SolidWorks guys is the programming, even though it may, you know, a bill of material is a bill of material is a bill of material to you and me, but the way it grabs properties in the background is it's a whole different way that it was programmed. So that's hence why they're a bit different, okay, in that. But what I can do now is I'll take here, insert column right, and that's the same. But when I go to add the property here, I just come over to the property manager and say, well, this is a cut list property. So we'll say bounding box length. Okay, I'll do another one, insert column right. And same thing here. And bounding. Nope, I want here. And, oh, there it is, bounding box width. All right, now let me just kind of position this a little bit. And with this. Now, this is something really important to watch, is the units. All right, let's take a look back at this other file here. Okay, notice here, this file is an inch pound second. Okay, this rod was all of 24 inches long. All right, now, if I go ahead and look here, check out the units for the length of that rod. It's metric. So, very important to note here is the units that you're seeing in here for length, bounding box length, bounding box width are in the whatever the units are of the drawing. Okay, so I'm going to change this here to inch, and we're going to see that. Now, in most cases, you're probably not going to have that issue because your template and your drawing, you're all most of the time potentially going to be all the same unit. You may have dual units on your particular drawings, potentially, but there's probably a good chance that your part assembly and drawing are all millimeter, inches, you know, again, all one and the same. But it's still something to be careful of because occasionally when you're pulling properties from, and that's not just sheet metal here, occasionally when you're pulling properties from certain things, again, sometimes we'll have title block, for instance, properties, unit-wise and or units and also decimal place are being driven by a part file versus the drawing file. So it's just those small things. I've always wanted to create a list of that. I always seem to forget after I say I'm going to make a list of that. But just be careful with that. And usually it's someone like me who's trying to do stuff on the fly that may run into it. You guys, once you get your title blocks, once you get your units, all that kind of good stuff set up, everything's going to be super nice and clean. Okay, with that. So, pretty simple. Now, if I were, even though this looks like, again, like an assembly here, if I did a bill of material, okay, a standard bill of material, and picked on this. Okay, now, let's check this out. Looks kind of interesting here. What's going on with this one? Well, there's a type of bill of material that we can actually take into account multi-body. Okay? However, notice the numbering system here. And I have to be in this indented format, okay, for the bomb type. So there's a no numbering, a detailed numbering, okay, and a flat numbering. All right, so I'm going to take here, and I'm going to put in a file property here at the top level, not any custom properties related to the individual bodies. All right, so this will be yet another description. And I'll just put my initials and just call this top level. Let me give it a save here. And notice what it is. So I've got a description here at my top level, and then I've got description of my multi-bodies. And again, this kind of is a bit confusing here. That assumes like, oh, there's 5 pieces. That's why there's, again, your detailed numbering here, that the .1s are those parts. Okay, so why would I use this? This is what I would use if I had an assembly that not only had multi-bodies in it, okay, like this, but if I had an assembly where I had multi-bodies combined with other components. Okay, so something, say here, let me find another simple assembly here. We'll just take we'll take the dice here. Let's make an assembly here. So just a bunch of multi-body parts, nothing, again, nothing, no weldments, no sheet metal, nothing like that. Okay, I'll just put this together here. All right, so now we got a kind of a mix of both. Let me go ahead and save this one. I'll call this the XYZ. And let's bring this into the drawing. Right here. And now I'll take on this, and I'll do, and again, I haven't assigned any properties to any of these bodies, or parts, I should say, in this vise. Okay, so it's going to be a little bit empty here, but now if I do, again, a bill of material on this one, okay, the top level here. Let's just, let me just number them here just so we can see it. Okay, 1 and 2. All right, now if I take this and I change that to a parts only, well, what I'm going to get here, and this is the other difference here, this is what I really like normal bill of materials, because you can flip this little triple triangle out here and see what these parts are. But if I notice here, these are all those individual parts from that vise. It's still only going to show this top level here. That is just one singular part. So again, indented now allows me to take that all the way to the next level here, right, and say, well, let's do a detailed numbering of this to see both of those. And so that's why we would do a normal bill of material, okay, but we have to use indented in order to see that. Now, how often do I see that? Not very often. Okay, normally, very generic bill of materials, 9 times out of 10, you're going to see that bill of material where it's top level, okay, and then subsequent drawings are calling these out individually to the point down where you get down to here and see a weldment cut list to describe my multi-body. Okay, and then subsequent pages here or other drawing sheets that would have our individual sheet metal components detailed on it. All right, so not a whole lot to multi-body. Again, the advantage there being as far as when things need to be drawn nice and tight to each other, hole patterns and everything like that, all nice and nestled together. I don't have to have any kind of mates to put these things together, so I'm not necessarily going to be using this as a, individual components of this. I'm not going to use this gray back bracket here in other assemblies. Okay? This is pretty much, when we do something like this, this is designed to be really kind of a single project type thing, or a small sub-assembly of sheet metal components that is just nicely working together there. Okay, so great question here. Can I take and explode a multi-body? And in 13, yes, we can. Okay, so I can take here, and it's the same place like we would do in an assembly. Right-click, New Exploded View. Okay, now, much like the weldment cutlass has a little bit of a disadvantage, this one does too. I'll show you what it is. Okay, it's not so much in the exploded. Right here. This pretty much acts all the same. All right, is okay. What we do not have is explode line sketches, okay, in this particular case. So we can explode it. Right? You can still take here. We can collapse. We can explode. The other thing here is there's no animation, okay, to do that, which I think for most people is not quite a big deal. Okay, so because there's no explode line sketches here, where I normally add them if I'm going to do something like this, okay, I'll come over here. Let's just use this view, and I'll click the Show in Exploded State here. Is normally what I would end up doing is I would do a sketch, right, with this. And what I would end up doing then is using the line type format icon here for the toolbar, is to pick this line and then assign it special properties. Thickness, chain dimension, that kind of thing, and right there. So, so again, a little bit more clunky with those. Really, Explode just came out last year, as far I believe. Sometimes it starts to blend together a little bit. I believe it was just last year, in 12, that we could do exploded multi-body parts here with that. So that's my workaround there, is to just simply do that. And I could turn on a couple of the sketches in order to say, well, I want like the center line of that tube to be collinear, okay, with that, in order to line it up, make it look nice. Okay, so great question there. All right, so any other questions? Anything, Corey, that came through that anyone wanted to see or show? Okay, so let me go ahead and pull this back over. If you have any kind of questions in regards to sheet metal, the sheet metal class,